When you're given an equation to graph in intercept form is A times the quantity x minus p times the quantity x minus q. A is still going to do everything that you're used to A doing. So A still tells you if the graph opens up or down. It still tells you how wide or how narrow the graph is going to be. P and Q are the x-intercepts of the graph. P and Q are going to tell us where the graph crosses the x-axis. And as far as the rest of it, we're just going to kind of get there as we do an example. The one thing I do want you to notice, do you see how it says x minus p and x minus q? But positive p and positive q are the intercepts. So the opposite of what you see in the formula are the intercepts of the graph. Let's look at this first example. And if you're working ahead, we are going to slightly change example B so that it's a negative in front. So if you happen to be working ahead, I just want you to notice that before you get there so you don't have to just totally redo the problem. Okay. So when we're given an equation in intercept form, our first step is going to be to use what we know from the formula. With vertex form, we started with the vertex because that's what it told us. With standard form, we started with A, B, and C and figured out the axis of symmetry and then went from there. With intercept form, we start with the x-intercepts. Anyone want to take a guess what the x-intercepts are for this graph? -2 and +4. The opposite of what you see in the parentheses. Anything inside the parentheses with the x is backwards opposite, just like with vertex form. So on our x-axis, we can put a point at -2 and at +4. A parabola is perfectly symmetrical. So these 2 points are reflections of each other over the symmetry line. That means that the symmetry line is exactly halfway in between these 2 points. Now, if you look up at the top of the page, they say the axis of symmetry is halfway between P and Q. So the axis of symmetry is add them together and divide by 2. Find the average of the 2 intercepts. So mathematically, we could do -2 + 4, get that answer, divide it by 2, or put one finger on one intercept, put another finger on the other intercept, and count in until your fingers meet. You're finding the middle line in between those 2 points. So I believe, did you find it to be 1? So our axis of symmetry is x = 1. That is exactly halfway between -2 and 4. If we know the axis of symmetry, we know the first part of the vertex. I suppose I should write vertex. So we know that our vertex has an x value of 1. What do you suppose we need to do with that x value to find the y value of the vertex? Plug it in. So grab a calculator of some sort. There. Ooh, I made that really small. Use the parentheses that are shown in the problem. So I would do parentheses 1 + 2, close my parentheses, parentheses 1 - 4, close my parentheses. And we find out that the y value of our vertex is -9. So on our graph over here, we are going to put our vertex at 1, -9. Personally, I love intercept form because the formula gives you 2 points find the middle of that, plug that in, you've got your vertex, and now you're done. I feel like it's the least amount of work of all of the types of forms that we've had. Don't forget to make your parabolas U-shaped. You don't want them to be V's. We also talked about in another class, make sure your parabolas don't look like this. They should not come back like they're going to run into each other. The ends need to continue out and up, not curving back in. The other thing that your assignment's going to ask you for is, does this graph have a maximum or a minimum value? Yeah. This one has a minimum, so you'd circle minimum. And what is the minimum value? -9. Remember that your minimum value, or sometimes maximum value, is the y value of your vertex. That will help you when it asks you for the domain and the range. Okay, sarcastic. I'm being very sarcastic right now. The hardest question of the day. What is the domain? Oh, wow. You guys are like so smart because that's just such a hard question. I'm being so incredibly sarcastic right now. I really hope you're picking up on that. Okay, your range. Range has to do with your maximum or minimum. So whatever your maximum or minimum is, because it's a minimum, that value is at the bottom. The rest of the points are above that. So y is greater than or equal to -9. Do you feel like you could maybe try this process on your own on the next one? I think you probably could. I'm going to give you some guidelines. So I will start with step 1, your x-intercepts. Figure out what those are. If you're watching the video, pause the video. Try this on your own. Your x-intercepts are the opposite of what you see in the parentheses. So I see -7 and -3. That means my intercepts are going to be +7 and +3. So there's +7 and +3. Halfway between those would be an x value of 5. So our axis of symmetry is x equals 5, which means the first part of the vertex is 5. Remember that the axis of symmetry is the first part of your vertex. To get the second part of our vertex, we need to plug in 5. So -2 parentheses, 5 minus 7 closure parentheses, 5 minus 3 closure parentheses, 8. So 5, 8. It should not surprise you that this graph is opening down because there was a negative in front. And if this graph feels a little bit skinnier than the previous graph, that also should not surprise you because a 2 in front is going to stretch this and make it a skinnier, narrower graph. Because the vertex is on the top, this would be called a maximum. And that maximum value is the y value of your vertex. So our maximum is at 8. And that maximum is linked to your range. So our range is going to be y something 8. Because the graph opens down, it's less than or equal to. And our domain, as always, is all real numbers.